Uh, so let's begin. Welcome everyone. Welcome to the fourth lecture of this workshop, which is on Matlab programming language. So far in last three lecture, what we have learned is use of programming language for engineering application. We learned about the basics of Matlab, utilizing various basic commands that are available in Matlab. We learned about how to do various plottings in Matlab. And the last lecture, which was the lecture three, which happened offline, there also we learned about creating your own functions, right? So if you will see, the lecture 3 notes are uploaded here, uh, PDF as well as all codes that we had developed during the class. So what we learned in the last class was that how to create your own function, which we can utilize for recurring tasks or automation of any other application part also, right? So it's just not related to your engineering applications. Creating your own function is kind of creating a subroutine to automate any task, right? So we saw various basic examples of creating the functions. We saw some scripting examples also, right? Then in the last class, I ended with the note that what was the issue when we were looking at this LMTD functional code, right? So if you remember, not this one, yeah, in class, we had made a function of LMTD where we ask inputs from users about the input temperature of hot fluid, cold fluid, as well as the output temperature of hot and cold fluid. Based on that, we compute logarithmic mean temperature difference for the heat exchanger. But here, in this function, the main idea that we had considered was the flow is co-current, sorry. Flow is the co-current, and based on that, we computed delta T1, delta T2 across the two end, and then we find the LMTD part. But we know that in heat exchanger there are two types of flows, right? So if you will look flow type in heat exchanger, obviously there are multiple types, but the main type that we considered and that you guys have learned is co-current and counter-current. So in counter-current, what happens? Both hot and cold fluid comes from the same direction and goes out on the same direction. In the co-current, hot fluid comes from the one direction while cold fluid is coming from the other direction. So in that cases, when we are computing logarithmic mean temperature, so that temperature calculation will also depend upon what kind of flow condition we have, right? So our previous function that we had developed to compute LMTD, it did not accounted for that part, right? So the idea was that we need further structural programming which identifies what kind of flow conditions we have. It keeps the checkpoint of that condition, and based on that, it will use the equation to compute LMTD for co-current or for uh, counter-current heat exchange problem, right? Uh, by that, what I mean is, so here we need a structured programming part. So what is structured programming? So right now what we are doing in MATLAB, so far what we have learned is, since MATLAB is an interpreted language, so whatever .m file that we are creating, it executes code sequentially. So line by line code execution happens. So in the same example of LMTD, where we had created a script file to find an LMTD. So how this code will work? It will execute each line one by one and then move on to the next, right? So that's what called as an interpreted language. So MATLAB is an interpreted language. But sometimes what we need is, we don't need sequential code, right? We don't need that it follows every line. We might need some conditional check, that if this condition is true, only then execute this part of code, else move ahead, or skip the code, right? So for the case of the heat exchanger that we are considering, right? So here what we want to know, that if the flow is co-current, then I would use different equation for LMTD. If flow is counter-current, then I will use different different equation, right? Mm, yep. So this is the example. So if you can see how the LMTD works is we take the difference delta T1 and delta T2 of one side. So here I consider this side as 1 and this side as 2. So here delta T1 in counter current is T hot in minus T cold out. Delta T2 is T hot out minus T cold in. While here delta T is T hot in minus T cold in, and delta T2 is T hot out minus T cold out. So based on the condition also, I have to use two different equations, like what to consider for this delta T1 and delta T2. So in that cases, we have to rely on the structural programming part. So in Matlab or in any other programming language, you will find this type of this type of structural programming part, which includes decision loops and the uh, uh, recurring loop. Okay, so it's a I should not say decision loop, but decision segment and the recurring segment, which are referred as loop, right? In statement or decision part, you have if else loop, if structure, switch structure that are available in Matlab, and then for loops you have for and while loop. So what we will do, we will start with this uh, decision statement first, understand how they are utilized, and then we will move ahead with the loop statement and how they are utilized. So as I mentioned, that decision statement, they are used for the selection purpose, while the loop statement are used for the repetitive task. So here, this four options that we have in Matlab for a decision statement is it's if else if structure. So first is the basic if loop, where you provide if some condition is met, then execute the part of code, right? So here, between the two syntax if and my code execution occurs. First is if it will verify the condition, if this condition is true. So for example, in our LMTD example, it will become that if condition is, let's say condition is flow condition, if flow is counter current, then only use the counter current equation and end the loop. If condition is, let's say, co-current, then use the co-current equation and end the loop. But this if statement only uses one condition. But then let's say you have multiple conditions in your system. Maybe you are studying the flow, fluid flow part. So there you are in laminar region, turbulent region, in between transient region, right? So then you have multiple conditions, and based on that multiple conditions, you might have to execute certain parts of code. So that's why if else structure is used. So there you provide multiple two conditions, that if first condition is true, then execute the statement 1. Else, if that condition is false, execute statement 2. So with this loop, you are executing two scenarios. If condition is true, one statement will occur. If not, then statement 2. Compared to the previous loop, if only condition was true, then only that statement will executed. Else, it will move ahead. Then let's say further addition to this code is if else if loop, where you have multiple conditions being imposed. So if condition 1 is satisfied, your statement 1 will be executed. If condition 2 is satisfied, then your statement 2 will be executed. So let's say condition 1 is, let's say, temperature part. So I have four different temperature ranges. If temperature is in range 1, it will execute statement 2. If not true, then it will go to the second part and check the if temperature is falling in the condition 2 or not. If it falls that, then the statement 2 will be executed. If not, then again it will go to condition 3 and check whether temperature falls in that part or not. Again, if it won't happen, then it will move ahead. Same way you have switch structure, which is similar to if loop, but here you provide some test variable and you provide multiple conditions for that test variable, right? So here I have switch loop starting as switch, ending with end. You have one test variable value that you provide. Now you check You put different case scenario. If case is that test variable value false is equal to the test value 1, then some part of code will be executed. If it is equal to test value 2, then the statement 2 will execute. If nothing happens, then the otherwise part will occur. Right? So obviously this is like basically looking at if this condition is true, execute this. If this condition is true, execute this part, else move ahead. Let's look at these examples and then I think you will get the idea correctly, like how we are using it. Okay. So if you recall, when I had started the first class, I had given the example of if number is divisible by 2 or not. No, sorry. If number is even or not, even or odd. And for that, we looked at the if if else condition where what we did was we divide a number by 2, and if the remainder is equal to 0, then the number is even, else it's odd, right? And that statement we looked across three different languages, C plus, Python and Matlab. So same thing, we will start with that simple code and try to understand and then move ahead with the other example. So first example is if number is even or odd. Sorry. Right? Oh, sorry. It's not even odd, but like this is the example. So we want to check whether number is divisible by 3 or not. If number is divisible by 3. So first, what I will do, I will ask an user to provide me a number, provide a integer number to check if it's divisible by 3 or not. Then, so this is how if and statement looks like. So if you will start if and so statement starts with the if condition starts with the keyword if and it ends with the end part. In different programming language, different approaches are used, different syntax you have. So for the case of C++ and MATLAB, you provide this condition in the bracket format, like here. Yeah. While in case of yeah, so here what happens in MATLAB, you start this condition with the if and keyword. Okay. Compared to that in C++, you don't provide the keyword and, but then you use this curly brackets. So this curly bracket shows the start of if condition and end of if condition. And while in Python, so it's a case sensitive and character sensitive language. So spacing between the lines will indicate when the loop is ending, right? So it's called as parenthesis. Yeah. So the spacing between different loop parts indicates when the loop is ending and when the next loop is beginning. So in Python, you don't have to provide if and end as a keyword or the bracket as a keyword. So there are syntaxes are different, but then at the end logic is same, right? So here in MATLAB, condition will start with the if, it will end with the end keyword, and then you put if bracket number that we want to divide, uh, whether it's divisible by 3 or not. So how we can know if number is divisible by 3 or not? So let's say I have any number here right now. I'm taking a as a 25. So remainder of a when divided by 25, if it equals 0, then it's divisible by 3, right? So for that you have Um, so like we have mod operator, yeah. Mod 25 comma 3. So if I look for the help for mod operator, what you will see is hmm, modulus after division. Okay. So it returns the floor carefully computed avoiding error. If y is not integer, then quadruple. Okay. So either you can use mod or RAM part. The mod takes it the positive sign, while RAM provides you the exact remainder value. So mod tries to round it off, while remainder will provide you the exact part, right? So either you can use RAM or mod, and the syntax is that first number that I have to provide, and then followed by the which number from which we are dividing. So if I do 20 RAM 9 by 3, it should come 0, right? Because 9 is divisible by 3. So either you can use that. So let's use remainder of number n by 3. If that is equal to 0, so for conditional check, what we learned was in the basic command part that mm, yeah, these are the various relation operators. So we want to check whether two values are equal or not. So double equal sign is used, right? So if this equal 0, that means now I know if that condition happens, that means number is divisible by 3. So I will print it out. So for printing, we learned that we use fprintf part, and I say that the number is divisible by 3. Okay. So let's save this and then run it. Number division. So if I run this code, it's asking me provide an integer number to check if it's divisible by 3 or not. So let's provide 9, and it says number is divisible by 9. Now let's run this again. Now I'm providing value of 24. 24 is also divisible by 3. Let's say 28. Now it doesn't show anything because 20 it is not divisible by 3. But right now our only conditional check is that if the remainder is 0, then only do something. There is no else condition. So let's say if I want to print out that also print if number is odd or not. So I will add further condition, which is else if the first part is not true, that means the number is not divisible by 3, right? I'm using slash n so that it creates a new line at the end. Save it and run it. So now again when I will add 28, now it will show that number is not divisible by 3. Okay? So it's a basic example. Now let's move on to the second example, which is modify the LMTD function of a heat exchanger to compute LMTD based on co-current and counter-current flow of fluids in heat exchanger. Right? So our previous example where we had created that, let's take it and modified it. So this is our LMTD function code. I'm copying it, making a new function here. Right? Now Oh, sorry, this is not a function. Anyway, we can work with the .m file also. Okay. So now here we are taking the temperature value from the user through input command. Also ask for the flow conditions. So now we will add one more check which will ask for the flow condition. So let's say you ask the user about the temperature value. Now ask for the flow condition. So I will create one variable flow condition equals input provide flow condition. Now here you have to provide an user an option like which exact keyword to use. I will come to that part why it's needed. Either co-current or counter current. Uh, hmm. So I'm asking user to provide an input condition, whether it's a co-current flow or counter current flow. User will provide any one value. Now I have to put a check. If flow condition is equal to co-current, if it's co-current, then whatever this code executes is exactly correct, right? So then it's fine. I can be okay with that. But let's say here I want to also check if what will be the LMTD value during counter current flow, right? So for that, I will put second condition. If first condition is not true, then check else if condition whether flow is counter current or not. Okay, let me put C capital here. Counter current. If that's the case, I'm just putting indentation for a better representation. Then in that case, delta T1 will become T hot in minus T cold out, right? Delta T2 will become T hot out minus T cold in. And then my LMTD value will be this only. I can end the loop here and then put my value as fprintf. The LMTD value for a given data is. Now either you can put the value here through %f or %d part, or also you can use a display command that is generally used to display any variable. So here our variable is temperature and I can do that. So this is modified LMTD problem. Now if you will run this code, it will ask for the hot fluid temperature, hot fluid outlet, let's say 50, cold in is 15, cold out is let's say 30. It is now also asking for provide flow condition, either co-current or counter current. So let's say I provide flow condition as counter current. Now see, it encountered an error because we have provided an we have provided an character string without the bracket here. So if I do now this, so it will recognize this as a variable, right? And once it is recognized it as now it's a counter current, it will go and compare and find the LMTD. For the same condition, if I run, so my previous values were uh, 88, 50, 15, 30, and this time it's co-current. So see, there is difference of 5 degrees centigrade in co-current and counter current value. Now, again, run the same code, but I provide a wrong syntax. So let's say I provide co-current, but instead of C is not capital. Okay. It should consider it as an error. Okay. Let's run it again. 88, 50, 15, 30. Maybe I provided this way co-current and then C. It's still executing. It should not execute this part because if flow condition is this, oh yeah, I remember. Sorry. So here what is happening is since we have ran the code previously, the temperature data is already saved, and our code at the end says that fprintf display temperature. So it's actually not computing the new data, but it's providing the previous value. So to avoid that, one good practice is to clear all variables at the start, clear the window. So when I do that and when I run the code, uh, sorry. So when I run the code now, you see all the variable has gone. CLC window is also applied. Now let me provide the temperature. And now I make a mistake of writing it co-current and the capital. So here see, spelling is same, but since it's a case sensitive, Matlab is case sensitive, right? So I have not provided co-current C in capital, but it's in small alphabets, right? So it's not recognizing it. So in that case, it's not computing any value because both of these loops are not executed. And then it goes out and tries to print this temp command, but it's not evaluated in between. So when this thing happens, what I would like to uh, what would I would like that I would inform the user that they have provided incorrect flow conditions, right? So you can add further text here, further conditions here, that if flow condition doesn't match co-current, counter current, then you print it out that flow condition flow condition is not correct. I would mention the user that they provide the correct data, which is it should be either co-current or counter current. Oh, it should be And now let's run the loop again. And now I'm providing it as co. Let's say I type it wrong, and let's see what happens. So it is saying that flow condition is not correct. It should be either co-current or the counter current. Uh, the project part should not come. Sorry. Right? So this is how code executes. Again, it's showing an error because anyway temperature value is not computed. So you can either put this display part in between in this loop also so that you don't get this error value at the end. Okay, so this is my neat and clean code now. Right? Same way, there is one more example which says create a program to compute the heat transfer coefficient based on the flow condition of fluid provided by user. Right? So we have to find the heat transfer coefficient based on the flow conditions. So if you will recall your so if you will recall your convection classes, the heat transfer through convection classes, right? So heat transfer coefficient is used for convective heat transfer. That too, it's more prominent specifically for the flow conditions, right? So this is the heat transfer coefficient. Flux is given by Q is equal to HA delta T, right? Sorry, that will be flow. Flux is just H into delta T because it will be per unit area. So your heat transfer coefficient is flow by delta T. Now here we haven't been provided any further information, but we have been provided that compute the heat transfer coefficient based on the flow conditions. So if it's based on the flow conditions, then if you will recall something called as the Nusselt number, right? So what is Nusselt number? It's a ratio of conductive to convective heat transfer, right? So it is given as the Nu is equal to HD by K, where D or L represents the characteristic length, K is your thermal conductivity, and H is your heat transfer coefficient, right? Now, this Nusselt number is related to the flow conditions, okay? So we have learned that when you are in a laminar region, Nusselt number is given based on the through this Dittelsbolt equation, where Nusselt number is related to the Reynolds number to the power zero point 0.8 or and Prandtl numbers to the power n, where n could be zero point 0.4 or zero point 0.3 for heating and cooling application, right? So this is for turbulent flow. Sorry, my mistake. Yeah, this is for turbulent part. While for the laminar flow, your Nusselt number is related to the Reynolds and Prandtl numbers to the power 1 by 3. Okay. So these two relations we have, and these two relations are given based on the Reynolds number and Prandtl number, which describes your flow conditions. So maybe we can create a code where we ask the user to provide the Reynolds number value, Prandtl number value. We ask the user to provide the heat transfer coefficient value and the characteristic length value, right? So based on Reynolds number and Prandtl number, based on Reynolds number, first you decide which flow conditions is there. If you know you are in the laminar region, you use Sider-Tate equation. If you know you are in the turbulent region, you use Dittels-Boelter equation. You find the Nusselt number based on these two equations. Put it in equation of Nusselt number, where you find the heat transfer coefficient. Since now you have Nu, you have characteristic length, and you also know what is the conductivity value, right? So that way I can create one function which takes this information from the user and computes the heat transfer coefficients. So let's look at the example for this script. Computing heat transfer coefficient. Just give me a minute. Yeah. Yeah. Okay. So what are the information that we will ask from user is first is I will ask user provide the flow conditions. So first is Reynolds number. Give the Reynolds. Then you also need Randall's number. So that is input. Right. Then I will say provide the fluid property. What fluid property we are asking for is the thermal conductivity. So which is K is equal to input thermal conductivity of fluid. Okay. What else we will need? We will need the characteristic length. So characteristic length is actually the flow condition part. So input provide characteristic length for the flow. Once I have this information, what we will do? We will run a if condition check that if Reynolds number, so I'm taking the 2100 as a value for a laminar flow. So if flow is laminar, then we will compute Nusselt number as 1.86 into Reynolds number to the power 0.3 into Prandtl's number to the power 0.33. Right? You can use the parenthesis for the better separation so that there are no mistakes on the order part. So I'm using this equation. If I'm in the laminar region, okay, so which is generally your Reynolds number less than 2100 value, right? Then you are in the laminar region, and for that you use this equation. Okay, I'm not accounting for this d by n and viscosity change part, just only the simple part. Obviously, you can add the further complexities here also. I will check that if Reynolds number is greater than 4000, that means flow is turbulent. Okay. If that's the case, then Nusselt number is given as 0.023 into Reynolds number to the power 0.8 into Prandtl's number to the power. Right now I'm considering 0.3. Obviously, this will also depend upon the heating or cooling requirement. Right? So these are the two equations. Else, I will say the user that you have intermediate flow condition Hence we are not computing this, the hence the code is not able to compute the Nusselt number there, because you don't have the equation for the in between part, right? Now once you know the Nusselt number, so nu is equal to hd by k, right? So your h will become nu into k by d, or L in our case, right? We are using this notation. So L, and this is your heat transfer coefficient value. Okay. And that way now you have created a code which asks the user this information and computes the heat transfer coefficient. Let me just quickly check if I have missed anything. Yeah. Greater or equal to. We are not printing the value. Yeah. Here, clear all CLC. Then let me put it here. F print F. The heat transfer coefficient value is, I will write percent %f, comma, and then h value, right? So this is our code. Now if I run it, obviously I'm taking an arbitrary values here. So let's say first I provide the Reynolds number as 1800, Prandtl numbers as 20, characteristic length as 3. Oh, sorry, I made some mistake here. F printf. Yeah, it should be F printf, and yeah, every output should be suppressed. Let's run it again. So I'm in laminar region, providing the Prandtl number value. Characteristic length is 5. Fluid conductivity, I don't know, I'm putting in arbitrary values, but obviously you can put the exact value here. And again, I made a mistake. It should be capital K instead of small k. 18, 20, 500. Okay, some print again by. And it is providing me the value, right? Same way, same code. Now let's say I am in the turbulent region, 60,000. Prandtl number value is some high. Characteristic is same. Conductivity is also same. So I'm getting the heat transfer coefficient value as this. Obviously, when you are running this code in actual में, you also have to account for unit conversion, unit consistency, etc. Right? But this is just an example that how this structural programming can be used to make multiple decisions for our calculations. Right? So if you will think about it, in all our chemical engineering applications, all the problems that you have encountered so far, there is this structure. Okay, either based on your flow type or based on your uh, fluid conditions, you execute you use certain set of equations. Same way it goes for the designing part also, right? So when you use when you use the designing equations, so there are certain conditions. If flow conditions matches in this part, then I will take this value. So if flow conditions is matching in this part, I will take this value. So all sort of decisions, if else decisions, will come under this decision statement that are needed for us to decide which part to use. And that again is a bigger part of the automation, that you have to implement this decisions statements inside your code so that you can make multiple choices while computing computing whatever problems you are solving and accounting for all possible scenarios. Same way, now there is this for and while loop. So these are the reputational loop. In for and while loop, what happens is that you start with some index value. So here the index variable starts with the value start, some code is executed, then the index value changes when you reach at the end of the statement part. Its value changes, is increases by plus step. Then again same statement is executed. Again index value increases by step value. Again same statement is executed till index value reaches the finished portion. And then the last time your statement value is executed and for loop ends. Here in while loop, it's a condition based loop. So what you have to do while this condition is satisfied, while this condition is satisfied, your statement will run. Once this condition becomes false, your loop will stop, right? So you have to provide some condition which will be checked every time. So let's say your condition is true right now. So statement is executed. When it reaches to the end part, again it will go back to the code. It will check whether still this condition is true or not. If that condition is true, it will again execute the same statement and same thing will repeat till the point where you reach a part where this condition is becomes false, and once that condition becomes false, your while loop will end. Okay, let's look at this then with a better example. So I have one code which is compute and provide the factorial of a number based on your code through for and while loop. Obviously in Matlab we can directly compute the factorial, right? So if I want to compute factorial, I will search for help factorial. So it provides me the factorial value, right? So factorial 4 is 24, right? Factorial 5 is 120, correct? So I can obviously directly use it, but let's say for the sake of learning this, I want to utilize for and while loop to compute the factorial. So how the factorial is computed? In factorial, what we do is, let's say you want to find the factorial of 5. So how we do it? We start with 1, add in second number, we move plus 1. So 1 into 1 plus 1, then 1 into 1 plus 2 times 1. Same way we add till we reach that number value, and this is how the factorial is computed, right? So can you see there is this repetition of the pattern, that first I start with the value 1, I'm moving one more increment that is being added to my final multiplication. Then again one value is added, that is multiplied. Again one value plus 1 is added, it is multiplied. Again plus 1 is added and is multiplied. So this is a repetitive pattern, right? So let's try to utilize that idea and compute the factorial. So first I will ask a user, provide a number for which factorial needs to be computed using for loop. So for loop also starts with the statement for. You have to provide some starting value. So I'm providing value I that will go from your start value to your end value. If I don't provided anything, by default, since we know that colon operator takes 1 as a step size, right? But still, let's say I provide it, it will end with the end syntax. In between, code execution will happen. So what will happen is I will find, I will create the variable factor is equal to 1, and then I put inside this vector, inside this loop, factor is equal to factor into I. Now, if you will try to understand what is happening here, so first the factor variable is created whose value is 1. Now the for loop will start with value of I is equal to 1. Okay. It will take the, now it will execute this line where factor is multiplied with the value of I. So 1 into 1, which is 1. Now, once it reaches the end part, I value will change from 1 to 1 plus 1, 2. Again, same code will be executed. Now see, factor value is will become 1 into 2. Okay, so now factor value is updated also simultaneously, right? So it's like this way that I provide A is equal to 1, right? Then A becomes A into 2. So here your A value is 1. A value multiplied, 1 multiplied with 2. So your A value is updated simultaneously. Now again, A value multiplied with 3. So 3 into 2, 6. Then A multiplied with 4. 6 into 4, 24. Right? So you are understanding what we are doing. We are using this recursive part where I am saying factor is equal to factor into I, where I is updated within this for loop, by this for loop. In this case, I had to manually update it 1, 2, 3, 4, 5. But here I have provided this condition that I value starts with 1 and goes to the n value, which is the user provided value, and it's updated. And at the end, I can provide user with the data that f printf the factorial value is %d slash factor. Okay, let's run this code. First, let me save it. Factor. Oh, I have to change the name of variable. Let's say right. File name and the variable cannot be same, else it will be confusing for Matlab. Okay. So let's say first start with 5 and the factorial value is 124. Again, I'm calling the code and this time 25, factorial of 25, and it's providing me the value. Right? So this is how the factorial value is computed using the for loop. Now, same thing I can use, same thing I can be done by while loop also. So let's learn how I can do that using while loop. So in while loop, what happens? So you have to provide some condition for which while loop will be executed. So my condition will be that, let's say I generate some variable, counter variable, count variable. It starts with the 1. Now this count variable, once is equal to n, is less or equal to n, then only my code should be executed, else it should end, right? So this is my condition, and in that condition I provide factor is equal to factor into count. Here I will make factor 1 again, okay, so that previous memory is erased and factor becomes 1. Now here what you can see, count value is initially 1, and if it's less or equal to n, then only while the statement within the while part will be executed. So that will happen. But here see, what is happening? The while loop will consider factor will become factor into count. So my factor is 1, count is also 1. So 1 into 1. Then it will reach the end statement. Again it will go to the top part and it will check whether count is less or equal to n. If it will find true, then again same thing will happen. So this loop is stuck. Here nothing is happening. It's iterating on its own without being stopped ever, right? So here I have to put the count value. I have to update the count value in between within the loop also. So I will write count is equal to count 1 every time loop is executed. So here what is happening? We started with the count value 1. Let's say 1 is less or equal to 5. Then factor will become 1 into 1. Now I am updating the counter value manually. So count becomes 1 plus 1, 2. 2 is less or equal to 5. Yes. So factor becomes 1 into 2. Count value becomes 2 plus 1, 3. Again 3 is less or equal to 5. So same thing will happen. Then till you reach the value of 5. So 5 is less or equal to 5. Yes. So factor 5 will become factor into 5. Then your counter becomes 5 plus 1, 6. Now when it will go to this condition, it will say that counter is less or 6 is not less or equal to 5, right? So it's incorrect. So then it will stop, loop will end, and you will be out of the while loop. Okay. Then you can put out the same thing and see. See, obviously the factorial value will come same. Okay, since the logic is same, but you can use both for and while loop to do the same thing, right? Now here there are some in between commands, also some terms that you can use. One is the break command, which terminates the loop in between. Now break command is generally used, so let's say you encounter some sort of a error, and you want to check like whether if some value reaches to some unbelievable part or some imaginary part, then your data becomes invalid, right? So in such cases you want to use the break part. What this break part does is it stops the loop within. Okay, in the sense that let's look at here. Here I am computing the factorial of 5 and it's giving me the value of 120, which is fine. But let's say I am computing the value of factorial of 200. It's infinity, right? I mean, obviously, it's not infinity, but the MATLAB calculation itself won't be able to show it. So it can go to some extent. Let's say 26 itself, it shows the 10 to the power 26 value, right? So it's very high value. So now I don't have to compute the factorial. I don't have to compute the value of factorial here 26 because I know it's not needed. Let's say my condition is that I need to compute the factorial value of the small numbers only, right? So I don't want to go till a higher part. Then you can put some check condition in between which says the check the value of n. If that value reaches certain part, then you end that loop. Okay. So let's look at the example if I have here previously. Uh, it's not there, but let me check. Clear. Yeah. Right. So here you can see I have a while loop ongoing. In between the while loop, there is one condition which is a check condition. if this temporary variable exceeds the value greater than limit, then you break the loop. So if this condition becomes true, loop will be break and your while loop will be terminated. Same way, for loop is you can also put the break condition in between for loop also or other recursive task also. We will look at the exact example when we will come to some problem statements and how exactly they are used. Another command is pause command. You can use the pause command to in between stop the code. So let's say right now the codes are very simple that we are doing, right? It's hardly a 27 line code, out of which obviously there are multiple spaces and comments also. But when you are solving a much bigger problem, there are multiple lines codes. You are doing multiple calculations in different sections. So in that cases, you can use the pause command. So it will pause or stop the calculation for certain time. Right. So there are this syntax. So if you use pause n, then it will halt the code for that time. Okay. But apart from that, if that pause command is in between the code, in between your recursive task also, it will halt the loop there. Then if you want to keep the track of time, then you can use tick tock command. So if I put this time here, let's say when I first execute the code, I put tick, and at the end I do tock. Okay, and let's run the loop. 5. You can see it is also giving me the elapsed time. See, I haven't provided any fprintf statement, but just tick tock command itself is computing it and providing it that the calculation happened within 2 seconds. So when you have to optimize your code and you want to check how long various condition takes to run, you can use tick tock command also to uh, to optimize your code. Okay. Now let's look at the second example, which is on write the code to find the area under the curve for a given between the for a given function between two limits using trapezoidal rule. Right. So if you will search trapezoidal rule, if you recall it, what we do is we break the function in trapezoid rule. Just give me a moment. You break the function in multiple small parts, and each small part is considered as a part of a rectangle. Not the each part is considered as a small rectangle, and you find the area for that rectangle, right? So let me look at the example here, yeah, or maybe this one. So this is how the equation looks like. That you want to integrate a function between two limit a and b. Then what you do, you divide the function into multiple smaller lines of grids, right? And then for each grid you find the values and do summation over it. Okay, so this is how the equation looks like. The area is given as h by 2, where h is the step size, this increment that you take, which is generally decided by two extreme limits b minus a by n. N is the number of strips or number of division that you want. More finer the division, more accurate the result, but then again it will become more, that many computation also increases, right? So it will become the computationally expensive also. So you have to decide between the accuracy and the optimum computational efficiency. Then you compute the value of your function. Here the function is y. at each of these data points. So y0 is value at a, y1 is at a plus h, y2 is at a plus 2h, up to yn, which is yb value, right? And then you put it in this equation and find out the area under the curve. Okay, so let's look at that example. So since we are out of time, what I will do is I will just go through the previous code that I have already created, and then explain you guys that part, right? So first is that you have to define which functions you want to integrate. Okay, so let's say I want to integrate the parabola for this example. So I have defined the function f by this part. So here I am writing at the rate, in parentheses the variable x, and it's written as x square. So this defines a function. So there are multiple ways of defining a function, right? We learned through that I can use inline command to define the function, right? Apart from that, you can directly define the function as this way, where I write f at the rate x and whatever expression that you want to use for that function. Okay, so it creates this function. So now if I provide f2, it will give me the 2 square, f3, 3 square, okay, 4, 4 square. Same way I can use the inline part, where I say f is equal to inline x to the power 2, right? So it has created the inline function. And when I provide the value, so I can compute this. So there are multiple ways you can create the provide the function. Search the function part here. So basically, what kind of functions, like what kind of method we will use to define the function? Either it will be the inline part or this symbolic statement part, right? So first we have defined the function in terms of the x. Okay, it will return the value of x square. Let's define the integration limit, lower and upper bound. So I'm calling it an a and b. Number of division. So right now we have taken the 1000 division. So the step size that we will take in the trapezoidal rule, that will become b minus a by n. Sum area 0. So now since it's a summation over multiple small division, I'm using a for loop. That for loop starts with the value of 1, goes to n minus 1, and at each value of I am computing the xi value. Xi value is a plus I into h, right? So I'm moving the next step in this moving the stepwise in the direction from a to b. I'm putting the summation. So sum area is equal to sum area plus f of the first and last trapezoid. So this is the equation, h by 2 f into sum area plus 0.5 f into b. So this is the same equation, just I represent it in a different form, right? So 2 is inside, that's why 0.5 times y0 and 0.5 times yb, y and yb, and display the result. And if you run this, change the file. This is what I'm getting the value. Now here in the trapezoid rule, as we discussed, that the number of division matters. So instead of 100, let's say if I only do 10, then my integration value will be different. See, my summation value change, right? So obviously there is limit, but then if you can understand, to compute this value, I had to do 1000 iteration, while to compute this value only I needed a 10 iteration, right? So maybe the area difference is here right now 2. So it might not be that much. So you can decide what should be the what is the accuracy that need. So if let's say the accuracy of plus or minus 5 is fine in the area value, then you can use the smaller step size. But if you are doing some coding where the accuracy is needed in the decimal points, right? in that cases, obviously you have to be very thorough and use the higher number to get the more better value. Okay. So now you can see this was with 1000, this was with 10, and this was with 100. So maybe 100 might be a good point in between where you are doing less iteration also and getting the optimum value also. So this will obviously you will learn more about it when you start uh, implementing various codes and try to optimize it. Okay. So this is one example of for loop. Same way there is last problem, which is to write the code to find the elements of Fibonacci, find the n elements of the Fibonacci series, right? And now, since we are out of time, what I would like you guys to do is that you try this code out. Obviously, I have already provided, I have the reference code ready, and obviously I will provide it to you. Right? So it's very simple, but first try it out with your own, and then if it doesn't work out, then check this part and understand what I'm doing here. Right? So that's it for today's class. So in today's class, what we learn is the structural programming, where we learn what are the decision statements and what are the loop statements that we use in the programming part. Now, with this data in mind, from the next class onwards, what I'm planning is to start working with the some of the chemical engineering problems, where this fundamentals of Matlab, the function creation, structural programming, scripting part, etc., will be utilized to solve the specific problems. Right. So my suggestion to you guys is try it out various things. Our next lecture will be probably on Thursday or maybe Monday. Till then, try it out, understand this. At least you should have the basic knowledge so that when we are solving the problems, you don't start thinking, okay, why exactly we are using this function, why exactly we are using this loop, etc. Right. So that's it for today's class. I will stop the recording.